Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want to just explain something in sets. We're looking at set 2, IGCSE, and we are on page 90, and we just want to look at one practical example. And we explain this practical example in an attempt to find out how can we present a Venn diagram and enter all the details to answer our questions. And we're told that in a class of 23 students, so let's get the details. Total 23, 15 like coffee and 13 like tea. There are those who like, let's talk about coffee, 15 and 13 like tea, and 13 like tea. 4 students don't like either drink. 4 they don't like any, none. How many like A, both drinks? How many like both drinks? How many like both drinks? And B, how many like tea only? And C, how many like coffee only? Yes, we are presented with such a problem, and we need now to come up with answers to this question. One thing, we are told that there are 23 students or 23 people in total. There are those who like coffee. There is a variable coffee and there's a variable tea. There are those who like coffee and there are those who like the tea. First of all, anytime we are trying to present a Venn diagram, this is a universal set, which is 23. Anytime you're trying to express information in Venn diagram, please make sure you start from the intersection point. Incidentally, in this question, we are not told how many like both. How many like both? In fact, that is the question. So we put X there. We are not told how many like both. But as far as coffee is concerned, 15 like coffee. And if within the 15 who like coffee, we already have X who are liking both, then outside that we have 15 minus X, because entirely the number of people who like coffee must be 15. So 15 minus X plus X remains 15. And 13 like tea. So in this particular part again, 13 minus X. But of course there are 4 who like none. So the question is, let's try to answer these questions. The number of who like coffee, tea, or both is actually supposed to be, when we collect all the information, then we are going to have 15 minus X plus X plus 13 minus X plus 4. We should get 23 entirely. And one thing we should do is collect the likes of 15 plus 13, that is 28. 28 minus 4, that is 24. 24, and we're talking about 15 plus 13, 28. Or this is plus 4, not minus 4. We should add everything. That is going to give us 28 plus 4, which is 32. X minus X plus X, that is gone. Minus X, we should get 23. We add everything to give us an entire number, which is 23. It goes without saying that 2 or rather, yes, 32 minus 23 is equals to x, and this is just 9. So yes, part A of the question answered. This is 9. 9 like both. The first question answered, part A. Let's go to part B. How many like tea only? How many like tea only? How many like tea only? Those who like tea only, 13 minus x, are the ones who like tea only. Because if we include this x, then we are also capturing those who might be liking coffee within the x. So, but our x is 9, so 13 minus 9, which is 4. 4 like tea only. 4 like tea only. And that is part B of the question. Let's talk about part C of the question. The number of people who like coffee only, again the same approach. 15 minus 9, which is 6, like coffee only. And basically that is simply the end of the question. Yes, we have seen that if you are trying to present this information in a Venn diagram, we must do so from the very middle point, which is the point of intersection, and build our Venn diagram from outside. Please know where to put what, and at the end of the day, you will have competently been able to answer all the questions in this particular topic. All right.